Lesson 39, Part 3 is properties of arithmetic and combining like terms. Go ahead and put the title into your notes and push play when you're ready to start. All right, first of all, before we get into combining like terms, you probably want to find out what a like term is. Sorry, I had like on there twice. So what is a like term? And this part that I'm writing down in red, you're going to want to write down into your notes as well. So a term, let's just look at term first. The term could be just a number. So a term is colon a number, or it can be a variable, or it can be a number mixed with a variable. That would be a term also. It can be a variable to an exponent amount. These would all be considered terms. So term, 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 term. So in math we could call those terms. And when we're talking about combining like terms, these are the terms. And real quickly, before we move forward into looking at like terms, I want to look specifically at, let's say, this term right here. Remember that means it's just an unknown number. It's a variable. It's an unknown number. What I want to point out to you here, though, is let's say I had given this variable, this unknown number, the term of apple. Can you pretend that's an apple? And I called it an apple. Well, how many apples do you see here? Okay, I know what you're thinking, Mrs. Sanchez. I don't see any apples there because that did not look at all like an apple. All right, pretend that's an apple. Okay, so how many apples do you see here? Your answer should be, I just see one apple, Mrs. Sanchez, just one apple. Right, it's one apple. How many X's do you see here? Well, I just see one X. So this X is the same as 1x. So whenever we're combining like terms, when it comes to the point we're adding stuff together, you can put the 1 in front of there. It's kind of redundant, but you can put it there. It just really means 1x. So x, go ahead and write this part in your notes, is the same as 1x. Any variable, j, is the same as 1j, because we only see 1j sitting there. There's just one of them. So I just wanted to point that out to you. Make sure this is into your notes. So now that we know what a term is, and we recognize that this term, if it's all by itself and it doesn't have a number in front of it, it's already assumed a 1. So if it's just going to be 1x there, then sometimes we just drop the 1 and call it x. So now that we know that, let's go on to the next part, the part of this lesson where we're combining like terms. So here's what we're going to do. We're going to take this expression and we're going to simplify it into its simplest form. And it looks really complex to do, doesn't it? But here's some steps to help you do it. And this is going to be an I do, where you're just going to listen and watch. But make sure you're paying attention and don't fast forward and skip this, because you're not going to learn this if you're just skipping through your lesson. So make sure that you stay with me on this. Make sure that you've got your game face on going through this. This one you don't have to write down, but you do want your game face on. So first you will need to be writing down the steps. You'll have to do it on the next one. You can pause it now and put them down now, or you can do it after this one on the we do. But here are the steps I'm going to be following. I'm going to fence it off. I'll show you what that means. Mark all the like terms. I'll show you how. I'm going to put all the like terms together by just kind of adding them together. And then I'm going to use the distributive property, which you practiced in the previous lesson. So here's how I'm going to go ahead and do this. I'm going to fence off all of the all of the terms. I'm going to put a fence after the end of each term, right after the end of each term. So here's my first term, and I'm going to put a fence right after him before the next sign here. And then here's my next term. I'm going to put a fence behind him. My next term is the x. I'm going to put a fence behind him. And then my last term is the 3. and I will put a fence behind him. So now instead of looking at these as add or subtract problems, I am only looking at these as positives and negatives. There's no adding and subtracting going on anymore. I'm just looking at these as positives and negatives. And this front one, since it doesn't have a sign in front of it, it's always assumed positive if there's no sign in front of it, so I can put positive there. All right. Now I'm going to go through and mark the like terms. And here's where you kind of need the definition here of a like term. Each letter, each variable represents a specific number. So NX is going to represent a specific number. If that specific number is going to be in the math problem again, they would use the same term, X, or the same variable, sorry, they would use the same variable, X. But if it was in there as a different number, they're not going to use X. X represents a specific number. They might use Y. X is not like Y. They are different numbers. But X is like X. So those would be like terms. So X and X would be like terms. X and Y would not be like terms. You might see X to the second power. Now you're talking about a different number. X is not the same as X to the second. These are not like terms. So they have to be the same letter to the same power to be like terms. So let's write that down somewhere. Like terms are the same letter to the same power. Make sure you get this down, okay? And if there's not letters involved, like here, and they're just numbers by themselves, those are also like terms. Numbers are like terms with numbers because we can add them together. So I'm going to go through and I'm going to mark all of my like terms, and I generally use pretty little shapes. So anything that has just the letter X with no exponent on it, I think I'm going to put circles around them. So this is going to go a circle around there. There's 3 X's here. This one does not have any X's at all. This has a negative X. Remember, if it's X, what number is supposed to be here? You're right. A 1 is there. It basically means a 1. So there's 1 X there. And you can put it there if it helps your brain to do the math when we get to that point. And so since that is a single X, I'm going to go ahead and circle that. So I have a positive 3X and a negative 1X. Those are like terms. And then this one doesn't have an X in it. Now I'm going to see if there's anything like this one. It is just a number, and this one is just a number. It's not a variable at all. It's not a letter at all. So those are like terms. So I'm going to put a triangle around those. And that's what I was doing there, marking the like terms. Now that I've marked all the like terms, I'm going to put my like terms together. Basically, I'm adding them. So I have just these ones in the circle I'm going to add first. I have a positive 3 and a negative 1X. Again, if you have $3 in your pocket, but you have to pay me 1, how many dollars are you going to have? You're right, you're going to have 2. So if I have positive 3 X's, and I have to give one of those X's away, I'm going to have 2 X's left. Cross that off. And now I just need to combine the other 2 like terms, the 5 and the 3. Well, that's the math you learned in first grade. You have positive 5 and a positive 3. How much do I have? I have positive 8. Good. Positive 8. Okay, and that's the step of putting the like terms together. So now I've put them together. Finally, to put it in its simplest form, I'm going to use the distributive property like we did in the previous lesson. I'm going to look at this and this to see if there's a common divisor that goes into both of them, the highest common divisor. Well, I know that 2 goes into 2 and 2 goes into 8. So I'm going to put 2 here. And 2 goes into 2 one time, so it's going to leave me with that x, 1x, right? So we can just say x. And 2 fits into 8 4 times, so I'm going to put 4. And that's my simplest form answer. I can't get it any simpler than that. I can't get the answer down to a one number like 12 or whatever, because there is not enough information here for me to make it final. When somebody tells me what x is, I can solve it from there. It's in its simplest form, so I can solve it quickly when somebody finally does tell me what x is. Until then, this has to do for the answer. Okay, so let's do the we do, and if you have not already written the steps down, then now you have to write the steps down. So number 1, fence it. Number 2, mark the like terms. Number 3, put the like terms together. And number 4, distributive property. And then go ahead and write down the we do problem. Push play when you're ready to do this. My first step says to fence it, so I'm going to go ahead and at the end of each term, I'm going to draw a line. That's the end of that term. Here's the end of that term. There's the end of that term. And there's the end of that term. So that takes care of step 1. I just fenced them off so that I'm not looking at is it add, subtract. I'm just looking at positives and negatives and not add or subtract. And since this one doesn't have a sign in front of it, it's got to be positive then. Otherwise it would say. All right, step 2 says mark all of your like terms. So like terms, again, are going to be, they're going to have the same letter to the same power, to the same exponent. If they have different exponents, they're not like terms. So we're going to do shapes around the terms and match the shapes together. On this first term, I have 4, and the variable is y to the second power. So I'm looking for anything that has a y to the second power in this whole thing. It must be y to the second power. And I'm going to go ahead and draw a heart around the y to the seconds. So I look at the next one. This is a positive 2y, not to the second power, not a like term. It has to be the same letter to the same power to be considered a like term. So not that guy. This is negative 2y to the second power. This is the same letter to the same power. Oh, I love this guy. And then over here I have positive 4y not to the second power. So this one is not a like term with these two. So not that one. Now I'll look at the next term. This is positive 2y to no power. So we're looking for y's to no power. So I'm going to draw, let's do a star, around all y's to no power. Obviously it's not going to be either of these two. They're already like terms with each other, and we already ruled this one out as being like term. This is a y to the no power, or to the whatever. So this is y with no power above it. So we're going to go ahead and put a star on that also, because it's this like term with this guy. These two are like terms. Now we're going to put those like terms together. So we'll put hearts with hearts, stars with stars. I have positive, how many y squares do I have? Positive 4 of them, and then a negative 2 of them. So I had 4 of them, but I took 2 away. So how many is that going to be? Yeah, I hope you got that. Yeah, it's 2. There's going to be 2 of them, 2 y squares. That takes care of those. Now I have a positive 2y and a positive 4y. So I had positive 2 of those y's, and then I got another positive 4 of those y's, another 4 of them. So that's a total of how many y's? I hope you got that. Yeah, it's a total of 6 y's. So now we've put the like terms together, and now we just need to distribute them. Look at the numbers themselves, just like we did when we were reducing or cross-reducing. A number that goes into both 2 and 6 evenly would be 2. So let's pull 2 out of there. 2 fits into 2 one time only, so I'm still going to be left with this y square, 1y square, right? Which we can just call y square. And 2 fits into 6 3 times. Oops. So there is your simplest form answer. That would be your answer until somebody tells you what y is. Then you can plug and play and figure it out. But for now, this would be your answer, and that's it. Now, some of you may feel like you're ready for UDO, and some of you may not feel like you're ready for UDO, but let's just do it. I don't want this video to go on too long. That way, those of you who get it can move on. And then I realized that if this is just a stumble for you, I can work with you in class and we can work on it some more. So if you still feel a little lost and here you're at UDO, don't worry too much. Just make sure you let me know and we can practice a few together. So this is the UDO. Go ahead and give it a shot, even if it gets messed up. Try the best you can. Push pause. Try to go through all the steps here, one by one, and push play when you're done, and you've gotten as far as you can get, and see how you did. You can see how far you got, and and then I'll show you the way through. All right, so you have some sort of answer, and I'm going to go ahead and go through the steps really quickly because this video is getting long, and I don't like it being too long. So I'm going to go somewhat quickly. Step 1, I need to fence it. So hopefully you fenced off the terms right at the end of the terms. So it should have looked like that. Step 2 is to mark all the like terms. Where I have X here, there's 2 of them. I'm going to go ahead and put a cloud around the X's. You put whatever shape you wanted. X it's not to any power, it's just X. That's not an X. This is an X. There's 4 of them. So I'll put a cloud around the 4 X's there. And this doesn't have X. Then I've got a number and a number. Those are like terms. So I'm going to put a diamond around those. Now I'm going to put the like terms together. Here I've got 2 X's. And then I have 4 more X's. These are positives. Remember, that's a positive there. That's a total of 6 X's. And here I have a 3, positive 3, and then a negative 1. That means I have $3 and I gave 1 away. So how many dollars do I have? $2. Finally, I'm on the distributive property. And what I notice is that between these 2 numbers, 2 goes into both of them. So I can pull 2 out and put it outside the parentheses. And 2 goes into 6 3 times, so that's going to leave me with 3x. And 2 fits into 2 1 time, so that's going to leave me with 1. And that would be my answer in simplest form, 2 times 3x plus 1. That's as far as I can go until someone tells me what x is. So that would be the answer. If this makes sense to you, go ahead and go get the closure and try that and bring those to me. If you're still really confused, you can get the closure, but we'll probably set up a tutoring table or something where you can come over to me and we can work through the closure ones together as well. It'll be extra practice, extra we-dos on that until you feel like you understand it well.